Getting everything ready to go here. So, welcome to the VDoorLocksmith show. Sorry for the delay, but we do have an absolutely amazing show set up for you guys today, and I am ready to kick this one off, and I'm probably going to skip through my introduction a little bit quicker than last time. So, I would like to say a special thank you to the person behind the camera. Has 30 years of experience doing video and audio. Are we not working now? What's going on?
No, we're fine.
Oh, okay. Sorry. Don't throw your hands up. That makes me nervous. Okay. 30 years behind the camera and has been nominated for an Emmy, has won a Cable Ace, and won many Telly Awards. This person is Rebecca Cunningham, owner of Red Flyer Media and also known as Mom. She is also the person that helped me build this desk and single-handedly built the majority of what you see behind here with the new studio. I cannot thank you enough for all that you do for me, for the family, and for this show. I appreciate it immensely. Next thing I want to be able to talk to you guys about is with this show, we have the honor and the opportunity of this platform to be able to give back to the industry. And so one of the things I would like to be able to start doing is if you've been laid off or you're currently unemployed, send us a 30 to 60 second video resume and we will run it during the show. We want to give this opportunity the chance for people who have seen the misfortunes of the cyclical nature and the high risk that's involved in this business. So we do have one video from an individual who did send me something. We ran it last week, but we want to be able to show it to the masses today. So here is a video of Farron Fowler and his video resume.
Hi, good afternoon. My name is Farron Fowler. I'm a 14-year MWD hand. Been in the oil and gas industry on and off for about 18 years. I grew up on a farm. I'm very familiar with heavy equipment operations, and I did move to the city at one point. Took an IT degree. I am familiar with both pulse and electromagnetic telemetries. I worked overseas in Europe, namely Germany, Austria, and the Netherlands, on geothermal activities there for about a year and a half. I also did off-coast Peru and onshore Peru, North Dakota, Williston Basin, and namely Alberta, BC, and Saskatchewan. The Canadian oil and gas market is facing some very tough times right now, so I have been sitting, and I look forward to getting back out there. And if you would like to get a hold of me, you can go on to farronfowler.com and click on Farron's resume. You can see my details there. You can download references and my contact information, or you can call me at 1-403-478-6658. Thank you for taking the time. Look forward to hearing from you.
All right, everybody, thank you so much. That was a quick resume by Farron Fowler. If you're looking for somebody, that is your man. All right, now back to the whole reason why everybody is watching, and I apologize so much for getting started late, but better now than never. So on today's show, we have the former chief drilling engineer from ExxonMobil and current faculty advisor of practice at Texas A&M University. It is Fred Dupriest. Thank you so much for being patient with me this morning.
Thank you for having me, David.
All right. I know that we've got tons of people watching. We're up to about 26 viewers right now. And a lot of people are going to have a lot of questions. So I'm going to hit you with a couple of questions to get started. And then as we get more people rolling in, I don't want to be rude, but I'll be checking my phone and checking the comments and stuff, and then just letting you know what everybody's kind of saying, and we'll kind of go from there. So for those that are not familiar with what you've done and what your big life work has been in the industry, I know that you can talk about this subject for days on end, but what is your quick elevator pitch as far as what your current mission in life is?
Well, I wish it was as quick as an elevator pitch. I spent 35 years in drilling before I retired, and in the last 10 of those, I was in a central technical organization in ExxonMobil, and we just took a different path. We for a variety of reasons, things came together where we committed to understanding the physics of the simple things and developing practices that were consistent with those. That was the market identity around that is fast drill. that evolved into what we call limiter redesign. And we had tremendous success, and it's more than just performance. It's really a change in the way you approach your business and drilling and engineering, and particularly operational practices. So when I retired, that has been my mission in the last 6 or 7 years, is to encourage the industry to move in that same direction. There's performance there, but there's also more than that. When you understand how things work, when you're treated like a very knowledgeable person, you're taught, you're given knowledge, and you work from knowledge, there's just a better life there. I mean, for everybody. It's very focused on the people in the field, creating knowledge there. The workflow depends on the knowledge being there, and it makes money. So we've got the perfect storm, and we need technology now. Technology is available now. There's a lot of things happening right now that make being physics-based and being driven to redesign limiter workflow, being driven by that, it's making it work. And it's the right time, and it's the right idea. So I've been able to work through students, basically former students at A&M. I teach these practices there, and hopefully some of those are online, but there's many of those students out in different drilling organizations helping implement these kinds of ideas and practices. And I work directly with companies as well over probably a period of months, individual companies that are wanting to go in that same direction. That's my mission. If I've got one in retirement, that and getting my 90-year-old house functional, that's probably keeping it functional now. But that's my mission in retirement and what I spend most of my time working on.
I remember one time we had a meeting when I was, and my takeaway from that meeting was I was like, Fred really enjoys looking at the EDR screen. Like, you really like I could see that there was passion in you watching the squiggly lines and being able to, kind of decipher and decode and find those little spots of like, oh, we could do this better or that better. So it to me is like, hearing about your mission and knowing what you're wanting to do, like there is true honesty in that is really what you want to be able to bring to the industry and be able to do for everybody. And it's not a a gimmicky sales pitch or anything. It's this is true passion or whatever that's coming out.
The EDR addiction is a symptom of a disease. It's the disease that matters. When you understand the physics, or you make a great effort to build bodies of knowledge around all of our performance limitations about the simple things. Every time you peel that onion, you learn something new, but the way we see it is through that digital data. If I had that digital data and I didn't have a framework of understanding of why the data says what it says, then I wouldn't be having fun. And that really is a key point. Where we're headed as an industry, a large part of the industry, is let's use the digital data stochastically. Let's mine it. Let's say that there was a relationship here and there and there, and that means so I should do this. We're basically finding the midpoint of our current practices by looking at data generated by our current practices. That stochastic approach is not what I enjoy. What I enjoy is understanding deterministically, just physically, how does that really work? If the data does that, then this is physically what's going on. And it's a really different thing. We call this being physics-based, and it's a fancy word. But what it really means is, how does it really work, being physics-based? So, the example I use a lot, because everyone's so familiar with it, is we were all taught to put weight on bit slowly. Pattern the bottom of the hole, break the bit in. Well, the bit's screwed on a sine wave. You rotate your string, your BHA is just going to form a sine wave, and the poor bit's being shaken all over the place, and we call that whirl or lateral vibration. And you really want weight on bit applied in 30 seconds, maybe 60, because by doing that, you bury that cutting structure, and now that BHA can't waggle the bit around and damage it. And who knew that, right? For all my career, we were taught to do the wrong thing. Well, the digital data, if you watch it, when you're first applying weight on bit, what you'll see is that the the energy consumption of the bit is huge. And you can see that vibration and the inefficiency. And as you apply weight on bit, you see the bit become more and more and more efficient. That's a really good example of, so not only is it a belief of mine, you should apply weight on bit quickly, but the digital data says the same thing. So it's really key that when you see that digital data, you've got to know what it means physically. If we take the digital data and we just mine it and say, you know, in a massive big data, I see this relationship, but we don't know why, then we can do some good, but we can't do the good we can do if we understand everything physically, what it means and why it means, or why it's happening.
So you're saying that, and this brings to mind something that I've heard and seen in the past about people dynoing the motors before they go in whole. And one of the things that they had said is that before you apply force to the dyno, that the motor's just like it's vibrating all over the place.
It wants the load, doesn't it?
Yeah, it wants that load. It's kind of, to me, it reminds me of like, how hard can I throw a tennis ball versus how hard can I throw a baseball? Like with that extra little bit of weight in your hand, it feels easier to be able to throw a faster pitch. So is that similar to what we're looking at as far as the bit, you know, getting back to bottom faster? Is that it's looking for that load?
It's similar, but in addition to dynoing, rotate it with that bend in it at the same time.
Yeah.
And imagine what that would do in that test stand. And that's what it's trying to do down hole. So, but I like your example. The point you're making, a point I would make is that I teach 134 practices in a single semester, and that's a lot. It's pretty intense.
I could say right now I'd fail that class.
No, you would. Well, my point was going to be, though, that you have an instinct from just knowing that about that dyno test. And when we say what is the physics of everything, we're not saying anything complicated. Everything that we teach in senior class at A&M, I teach to drillers out on the brake handle, directional drillers, company men, whoever I work with. We all have really good physical instincts. The key is just to connect it to what we see in a logical way, have structure around understanding what we're looking at. It's not that it's complicated. No more complicated than you seeing what happened in a dyno. We all have good physical instinct. How it really works isn't complicated to explain in a way that's really useful for making good decisions in real time and in engineering redesign, both.
So that brings me to the question, something you touched on there is as far as being able to train and educate people. So I know that you're working a lot with the operators. What is something that, you know, other than, or I should say this, is it possible for service companies, directional drilling companies, bit companies to be able to bring you in and be able to educate them up, as well as kind of the second part of the question is what can the service companies do on their side to be able to work better with the operators and be able to bring a better service when knowing that they don't have full control of the scope of the project?
Well, I work with a lot of service people teaching. I've never been a service person, so I would speculate some on that. But with the people I work with teaching and then following up, and I continue to work with companies after I train, look at their digital data every day and talk about their limiters and help help them to change the way they work. My impression from having worked with a lot of companies is that the operator's engineer, drilling engineer, or organization as a whole, there's certain decisions only they are going to make. So you're a directional driller, and you know as you increase weight on bit, the energy consumption of the bit's getting more efficient. It's good. Keep doing that. It's good. Keep doing it. You keep increasing weight on bit, and you know that you're suppressing whirl. That's great. Well, then the operator says, but stop at 30,000 pounds because that's the bit company's recommended weight on bit. Well, you don't own that as a directional driller, and you don't own the operator's decision to stop you. So if you had the physics-based understanding of how deeper engagement of the bit with the rock prevents it from whirling and wearing, that'd be great. But you can't necessarily exercise the decision. So I think the answer to your question is that first, we need directional drillers, operators to understand physics. Have a common view of the physics of the dysfunction, the issues that they're seeing, so that you just have a common language and a common understanding. And that's basically the first step in the path forward for everybody, is understand how the thing really works, not how we put weight on bid all these centuries, whatever. But how does it really work? And with that, you and I having the same understanding, then if we have a conversation about it, we're both pretty reasonable people. We're both logical. Why would you come to a different conclusion than me? So it's somewhat about fertile ground, but being physics-based as opposed to being experience-based actually kind of puts us on the same footing immediately, and it brings down a lot of our defensive positions. If I'm experience-based, all I know is what I've done and then the results of that, which is really important. But then our conversation is, my experience is better than your experience. Right? So it's different.
Well, I'll agree to that statement right now, but yes.
Not if it has anything to do with the internet. Okay. So the let me put a bow on that, is
Yes.
that if you're a young engineer, if you're a young directional driller, if you're a service hand, try to get yourself in a position where you understand the physics of things, not the best practice, not the standard practice alone, but why is that a best practice? And then develop the ability to explain it to other people. And be physics-based yourself, deterministically understand how things work, but you also have to develop the ability to explain it. Don't go in and say, here's what you should do. Go in and say, here's how it works. And then let them figure out the same thing you figured out, right?
Yeah.
So I've seen the physics-based approach that we've really developed at ExxonMobil, work there. But I've seen it work with all major independents, and where it really works is for the young person, because your option is to hang around and have experience for 15 years before anybody will listen to you. But if I can come into you and waggle my arm and say the bit's screwed on the end of this sine wave and you need to apply weight on bit quickly, doesn't that make sense to you too?
Most definitely.
Okay, so that's a key point. In your business relationship, it's going to be hard for you to do everything that the operator can do, because you don't own all the decisions. But if you can find ways of teaching and explaining and having the same level of knowledge, you may not have an argument, and that may be the preferred approach. Now, I would love to see service companies, especially those that offer multiple services, attempt to apply this, meaning teach. Actually organize the physics, put it into training, present it to the people that they work for, teach the people that they work for. I'd like to see that in an organized fashion, but from a business model standpoint, it's pretty challenging. I can do it a little bit more as an individual than I can get a large service organization to move in that direction. I am aware of one rig contractor who is working very hard to develop that model, where they would be the contractor that came in and offered a relationship where they would do many of these things. They'll learn. It's not that you can't do it, it's that you're going to have a special kind of relationship, and the operator, and all of your parties involved are going to have to find a business model that works for everybody.
Well, as far as business model, you said that this practice makes money, and you had said prior that what's the value or the reduction in time? You'd given me a number beforehand, and
So what I do with the company is I go.
Hold on, just a second.
Get a little help.
Your movie's over. Is it all right if Mimi goes in there and starts your new? No, don't touch. You're not supposed to touch Mimi's cameras.
I'll go start
Sorry,
there.
guys. Hold on just a second. Wesley, no, sir. No, sir. sir.
Okay.
No, sir.
I got
No,
it.
sir.
If you guys want to continue talking, and we will go. Come on. Let's go. What? I have a question. No.
Sorry, this is a family show.
Okay.
So if anybody of you guys don't know, I am a single dad of 4-year-old twins, and they are my life. So they're here at work with us today and have met Fred and plan on being drilling engineers someday. So sorry about that.
Yeah, they're very involved.
So the question is, you told me beforehand that some of the companies you worked with, you were saving within 2 to 3 wells, you were cutting off a certain amount of time on the.
It's very common when if you can hand somebody a lot of knowledge about how things really work, then you sort of just get out of the way, because if it makes sense to do something different, then they just do. So that's kind of philosophical, right? I'm waving my hands around here a little bit, but where does the real change in drill rate come from? It's the person on the brake handle or the joystick. They have to do something different, and you always have to keep that in mind. If you're an engineer wanting to change performance, it doesn't matter how many studies you do or what data you have or what knowledge, or maybe you're in a data analytics group and you've discovered some relationship. If you don't have a connectivity where the person in the field does something different with weight on bit, RPM, or GPM, or maybe you redesign and physically change the system, you don't get different performance. So we do see really large performance gains with a small amount of training. Where it comes from is weight on bit. So bits are really, and it's really important to be very simple, clean, and not too complicated about this. So bits are really simple things. We put weight on bit and they indent. If I double my weight on bit, they indent twice as much. If they're efficient, if they're operating efficiently. And I rotate to the right, I just destroy twice as much rock per revolution. So that's just really simple. There's this linear relationship between these things. So if I want to drill faster, it's a simple thing. I just put more weight on bit. Or I increase the motor speed, use a faster motor, or turn my string faster. So I get linear responses. The key in our industry is that you add weight, you watch it, you do step tests, you add weight, you add weight, you add weight until you don't see that linear response, and that means something's wrong. It should be linear. So,
And that's the limiter approach.
that's the limiter. That's where the limiter redesign comes in. We got physics-based means, but limiter redesign is I actually physically go out and I do step tests. My well, my rig, my system right now, and I have to be trained how to do that. And I have to be trained how to identify when something's going wrong and stop raising weight on bit. And we know the reasons: bit balling, bottom hole balling, vibrations, interfacial severity. They all have physics, and in every case there's something the driller can see, do, and decide right now that extends the weight they can run, meaning the ROP, before they have dysfunction. And in every case of dysfunction, there's a lot the drilling engineer can do to redesign the fundamental system so I can run more weight. And that's the kind of the limiter redesign. So the workflow is raise weight on bit until something limits you and redesign it. And it might be dysfunction, but it might be motor differential. It might be that your auger on an offshore rig can't handle any more cuttings to the barge. You have to physically.
I remember that story you told. Yeah. Go ahead. Tell the story, because it's a great one.
Well, I wish it was one story, but offshore augers all over the world are limiting a large amount of footage. And it could be a bunch of different stories. But it really illustrates the need for workflow that really drives the organization to identify and redesign what limits you, because most things are normal. It's what you'd call normal. So you've got an offshore platform, and they're drilling 100 feet an hour in a very long extended reach 12 1/4 hole. And if they drill faster, the auger packs off. And you go out and you identify it now. In the workflow, you say, our limiter is we can't raise weight on bit because the auger is packing off. And so now I have workflow. I didn't before, but the workflow kicks in. Well, I'm required to do something about it right now. Even though it's normal and I've been doing it for a while, I know I have. So they did, and they go next day. Well, they had a auger that snaked down, went through a bulkhead, and was 9 inches where it went through the bulkhead, and that's the only thing that was packing off. They went through a difficult permitting process to get the bulkhead cut out, a bigger auger. Next day they're doing 300 feet an hour. Next day. So I had a class I was teaching, and an individual who had worked on that platform 20 years ago. And he said, I know that platform. And I said, well, when you were on it, what was your limiter? Well, we had this auger that necked down to 9 inches. And if we went over 100 feet an hour, we'd pack off. He worked on that platform 20 years ago. So the things that limit us aren't necessarily these dysfunctions. They are lots of things. If you were to say, go out and solve them all, you wouldn't make money and you'd be solving the wrong ones. You literally have to have a crew on a rig, in a well, in real time, run step tests, find what limits them in their well right now, in their rock, and identify it. And then you have to have a process where they are good at telling engineering, go do something about it, doing what they can in real time. They have that knowledge, you had to teach it. But engineering also today doesn't have that knowledge necessarily because they're not being taught either.
Yes, sir.
But they have to have that workflow where engineering goes and does something about it, and that's how you continue to make progress. I'm going to come way back to your original question. Most of the ROP that you see in the first 2 wells is because we're currently, as an industry, going out and running a constant weight on bit for all 6,000 feet of that 12 1/4 hole, or 10,000, or whatever the length. We get a recommendation from the bit company and it's 30,000 pounds. But if you actually did step test every 500 feet and you went through that process of identifying what limits you as you go through all these different strata and formations, you would see it changed. You're going to come out of your casing chute in the Delaware Basin at surface casing, and you can probably be running 60,000 pounds easily on 12 1/4 bit and drilling really fast. But when you get to the maybe lower Cherry Canyon or the early, the hard laminated streaks that start to come in the brushy canyon, you need to reduce the weight on bit. If I know how to run high weight on bit, do step test, and know how to quit, see when I have a problem, see when I don't have a problem, my well starts to segregate between where I can run very high weight on bit and where I can't. Now, as a driller, I can do that immediately, and that's where your 20 or 30% comes from. It's simply not running the same weight everywhere. But I won't do that unless I have this ability to know where I can and can't, and I won't do that unless I have some physics-based understanding of how things work that I may not be taught right now. So that's not a trivial thing to say, run more weight some places and less others. It takes a lot to get there, maybe.
So, in saying this, a lot of this is dependent upon a drilling engineer being a drilling engineer. And I know that one of the guys that possibly might be watching is Brandon Foster with Total Depth Unlimited. And I remember he had, at one point in time, presented at IADD, and his big call to the industry was make drilling engineers and not paper pushers. Do you see that as an epidemic and a problem in some of the organizations that you've either dealt with, either directly or indirectly, that a lot of these drilling engineers are just becoming invoicers and accounts payable, accounts receivable, that they're chasing so much on the dollar side of it that they're not even looking at the gains that they could make on the performance drilling side of it?
So I've been doing this for quite a while. And the little secret is that's what they've always been. They've always been administrator, pushers, logistical people. The act of designing casing, doing some hydraulic calculation, calculating the lowest cost per foot from offset bits doesn't take any time. That's the engineering that you're typically taught in academia, but it's also the expectation of engineering in industry, always has been. When we started doing extended reach and more difficult wells, first thing that happened was digital data in the 90s. So now as an engineer, I can actually see operations. I never could before. Then what happened was extended reach and torque and drag modeling, really. And I started getting into operations because I had to model operations. So you start to create more connection. You know, engineering in the past was kind of do a program and throw it over the wall. But when you got $80 million wells getting stuck because of bore instability, or they don't have the torque or drag capability to get to the objective in the end, modeling and more engineering becomes important. So it was really modeling for feasibility. Is this well feasible? That's what Brandon and K&M did, right? When he was with them, that's what K&M does. They model, do you have the feasibility, or Merlin or whoever. And many companies got their engineers into that ballgame in the extended reach environment, but pretty much only there. So you have parts of our industry where we're starting to engineer operations a little bit. Still, you're not engineering performance. You're trying to avoid trouble. So we started engineering to avoid trouble, but we're still not engineering performance. And what we're talking about now is not having trouble either. But now we're looking at, you know, what limits us from drilling all of our 12.25s at 1,000 feet an hour. And I'll tell you, in worldwide, not much. Now, there are some things, but they're all engineerable, redesignable, and fixable. So that any 12.25 or above about 8,000 feet TVD, almost anywhere in the world, you can probably get yourself into the 700 to 1,000 foot an hour range. Who would have thought that? You cannot do that day one. You raise your weight on bit till you see what limits you, and you redesign it, and you see what limits you, and you're buckling, and you redesign it, and you see what your limits you, and you've got you've got this other performance limitation. So we're in new territory, and it's a different thing to say. So management, what we really need is for management to understand the opportunity, and they grew up in the 70s and 80s and maybe a bit in the 90s now. The big crew change is over, and unfortunately the new crew got taught by the old crew the
handover notes did not improve the situation.
There wasn't a new model with that. It was, you know, stay out of trouble, engineer for feasibility. But I have to say what happened at ExxonMobil is we caught the big crew change. So the young people who came in from 2000 on, who run ExxonMobil today, they already do, because all of us left and we're driving RVs around. You know, those young people are doing phenomenal things. They have a different expectation of themselves. They have a different view of things. My students, who I talk to frequently out in industry, are doing great things. They need the industry to move with them somewhat. But we need management that sees this opportunity and it can envision that engineers should be engineering performance. And most of the industry is not quite there. I think we're getting a sense that we should be going there, and you see people developing data analytics groups, doing some things. But we need a pretty significant leap forward before we have this mindset that we're going to engineer performance limitations in every foot of hole we drill. We're not there as an industry. A few companies are headed in that direction.
So I would say this to any of the companies, especially if you're a directional drilling company, if you are working for a company that you know Fred is helping out with, it would probably be a good idea to be dollars per foot versus dollars per day, because you know that it's only going to get faster. So that's going to help out your margins quite a bit. So I have asked you a bunch of questions so far. Okay. Let's see if we can turn it over to the audience. I've still got more questions. I could ask you questions all day. We already know this. But let me turn it over. Let's see if we can find a couple of quick questions here from the audience while I get this pulled up. And I guess while I'm trying to get this pulled up and I hear one of my kids about to run in here again. Yeah, let's do it as quick as I can. So if any of you guys have questions out there, please start to fire away. Let us know what the questions are. And I'm trying to get this pulled up on my phone. Are you seeing any live
I am
questions?
not able to pull it up. We've got really bad internet. We're streaming. I know that much is happening.
Okay.
So I can't pull anything else up, so.
Okay, well, while we're waiting to be able to get a good connection going again and probably getting one of the kiddos back in there to watch the movie, I'm going to ask you this one. So talk me through a little bit of how to address the cultural issue of whether it's at the rig site or in management of the operator to be able to make sure that even if it's like, okay, hey, we're going to do this, but the incentives aren't the wrong direction that make you go back to the old methods.
Don't target cultural change.
Well, there's a good one.
What you do is you change the way people are working mechanically day in and day out, and you do it in a way so that it creates cultural change. If I live a different life, I mean, every year I target losing weight, right? But I don't till I go on a diet. And then it's pretty much the same. I become how I work. And so that's not an easy path, and it's not hand waving or a lot of philosophy. So if you want to be a limiter redesign driven company, here are some key elements to that. First of all, we are basically management by objectives companies. That's what we are, what we have to be. You know, we have money, this level of management's told, I want this from you, and they trickle that down, and the directives come to the bottom, and we say, and we all have to be coordinated. So what happens in all of our companies is that we establish business objectives, and you give me an objective and I promise to go achieve it. And that's what we call management by objectives. And in a year we come back and I say, did I do it or not? That creates a culture where I don't promise anything other than what I know I can already deliver, meaning how I worked last year. It's basically how what I'm promising you. That creates really resistance to change. It's essential because, you know, if you don't test BOPs the way I told you to, I'm actually going to fire you. And I want you to test them the way I told you to. So we have to have practices, we have to make promises, we have to keep our promises to have uniform, predictable, safe operations. But that becomes our enemy in the long run because it keeps us from changing. And so the way you want to approach your business is be who you are and be good at it, but identify what limits you. One thing. Your well right now, your practices, and change and make that who you are. Then identify what limits you, change and make that who you are. You need to be methodical about that. So that's the first thing, is don't throw your whole organization in turmoil. Be who you are. You have a business model, it's working for you. Find the thing that limits you and work on that, and then make it part of who you are. The other thing is that when I say mechanical work devices, limiter redesign, all performance improvement processes are some form of a plan, do, analyze, plan, do, analyze, plan, do, analyze. That's continuous improvement. That might be 10% of your business, not the 90%. Okay. In your workflow, bury those things that drive that cycle inside your routine daily workflow. For example, so you did step test, you identified that bitballing was limiting you. And you told the engineer bitballing's limiting me, or did you? Did you tell the engineer bitballing, well, does your daily report require you to write down what limited you, what did you found on that step test? Yeah. Like digital data, I can see you did one, but did you tell anybody so that it gets redesigned? A blank on a piece of paper where you write down what limited you is a mechanical workflow device that ensures the engineer can see what limited you. Access by the engineer to your digital data is a workflow device. 1 second data instead of 30-second data, which I need for the engineer to share a stick slip, be able to see the same stick slip I'm seeing on the rig. Those are devices. Continue to work those things in. You've got 7 rigs running with 7 engineers. Do they meet once a week and share their learnings? Did you invent that workflow? If you just continue to invent the workflow that makes your limiter redesign happen, in your business model, your company, your overhead, your people, something that works for you, and then have them do it and do it and do it, you'll wake up one day and you'll say, wow, everybody likes change. They engineer the risks before they change. They're having a good time. Our retention of engineers is better because they like being respected, appreciated, and doing real stuff. And you wake up one day and you say, I think we have a different culture. Create the workflows that support the behaviors you want. Expect that as management and leadership and the staff, you're going to lean into a hard win for 2-3 years, maybe 4. But you'll wake up one day and say, you know what, I think we're different than we used to be. That's how it happens.
Excellent. Well, in that amount of time, we still haven't been able to get the video feed working. Are we live still?
We're supposed to be. Everything here says we are.
Okay. What's running off of your internet versus what's running off of the house internet?
I am on running Rabbit's laptop, and there has about 15 windows open. And I closed a bunch of them down, so I do not know. This is
it running off of
This
you?
is going through the Netgear 28.
All right, guys, we're trying to be able to get to where we can get some questions. I'll say this, if anybody has got my, let's see, nope. I'm trying to see if we've got any questions. If you guys can hear this, we do have the thing down at the bottom of the screen, which is the email address, VDoorLocksmith@gmail.com. Send us an email there, because being able to see the stuff in real time on LinkedIn is not always the best option. It works sometimes in the beginning, but then today's one of those difficult days where we've also got the kids kind of running in the background. Now, I do have a person that is watching that did text us. Jessica says that we are live, we are going. So
Good.
We're trying to be able to get to your questions. Just email the questions to, thought of this ahead of time, to VDoorLocksmith@gmail.com. So I'm waiting here. If you want to make it an anonymous comment, make it anonymous. I won't read off who the email address is from, who the person is. If you just have questions for Fred, for myself, mainly Fred, we will read them. So I'm still waiting to see if we get anything there.
Or whoever texts you, tell them to text you the question.
I'm trying to see. Somebody from a 432 number just texted me and said, y'all are still live. I'm not sure whose number that is, so if you are watching, please text me your name, because I didn't have that one saved in there.
Oops.
Feel bad now. All right. Let's see. Neil Bergstrom says we are live. So good. So I've got a couple of people who are telling us that we're live. So start firing away some questions. I'm going to try to, so I've still got a couple of pre-planned questions, which is good, because just in case stuff like this happens, I'm going to turn the volume off on this now so it doesn't keep interrupting. So one of the new big things that I've started to see in the industry, and I know that you've got a little bit of work in this area, is geothermal. So how closely related is what we're doing on the drilling side in the industry? Because like I've made this conversation with people, like if oil and gas disappeared right away, we would still need drilling rigs, we would still need MWD, we'd still need drill bits, we'd still need motors to a certain degree, not one for one, but that industry doesn't just disappear just because, new government or, the snap of the fingers that all hydrocarbons disappear.
Yeah.
So as there is a push around the world in different areas and different political parties towards, quote unquote, green energy and stuff, what's your take on as far as the geothermal drilling and kind of that movement, and how do things kind of correlate there as far as what we're doing right now?
I've had some direct involvement with the geothermal industry. I actually went through a physics-based limiter redesign rollout initiative with a geothermal company a few years ago. The geothermal, just like oil and gas, is dependent on the resource. If you have the resource, then you have an opportunity. If you don't, you really don't. So the real basic challenge in geothermal is high heat near the surface. Where do we have that? Is it hot enough? Is it close enough to the surface? And it has those, the heat is its equivalent to hydrocarbon. So the challenge in many parts of the world is you just don't have the resource that will pay for itself. Then you have the gray area where now your performance becomes important. But I would say that there's just not a lot of places in North America for sure where we have a lot of that intense resource. We have some, and for them performance is important, and what we do in petroleum is no different than what they do. The rock cutting, whorl, the drilling dysfunctions are the same. They have a tradition though that's extremely separate, so the knowledge doesn't move very well, and that is an opportunity for them for sure. Their rigs are underpowered. One rig we worked with couldn't trip and leave drill pipe in the dirt. They had to lay down every joint, pick it back up to trip. Now that they can go get more powerful rigs, but they're in a cost bind and a performance bind. Yeah. They survive through subsidy. There are places in the world though where it's quite profitable.
Oh, really?
Well, where I have more heat, closer to the surface, more favorable reservoir conditions, basically, and some places in the U.S. So that's kind of the challenge for them. But the physics are the same. Their rock is much harder, much shallower, so they're very whorl dominated or laterally vibration dominated. But they are not maybe applying all of the practices that we have in the drilling industry yet to manage that. So you see opportunity there, and there are some efforts underway, some funding underway to try to continue to move practices over.
So just like any other reservoir, depending on its, how profitable it can be, they're going to face those exact same issues with the with the geothermal stuff, so it's how thick is the reservoir, how fast can it flow, how long is it going to flow for?
And because they're federally funded and really are dependent on that to be economic, they have that extra complexity when they're trying to do their economics of deciding, how whether and when to make investments.
Okay. So what I've done here is I've actually gotten a couple of people to be able to text me questions. So we've got Chad Curry. Could you comment on the lithology and geomechanics? I've frosted red in certain formations were the only way to notice stratigraphic variation in ROP and tool vibration is to experience. Okay, that one's a little difficult to read, so I'm gonna try the next one. Okay, Farron Fowler asks, is it often more difficult in large companies to push through new approaches, or is it more difficult to overcome the old school mentality?
So let me go back to the last question because I know where they were going.
Oh, you know where they're going? Because I think it might have been.
Can we use dysfunction in the drilling process to identify formations? And
whether that's the question or not, I think that's a great question.
I think that's where they're trying to go. And the answer is sometimes.
Okay.
So we haven't talked about mechanical specific energy yet. It's a common idea, but that's the energy we use per volume of rock. It's calculated continuously by your EDR company, and you can plot it as you drill. In it, what we see is a correlation between the energy per volume of rock, the MSE, and rock changes. The reason the MSE is really talking to you is because of the level of whorl or lateral vibration is changing. So the bit's becoming very inefficient as a result of very small changes in rock strength. So if I look at an MSE log and it's very ratty and it's spiking and it's jumping off, basically my bit is whirling, not whirling, whirling, not whirling, whirling, not whirling. And where it's whirling is probably in most cases tied to a little bit firmer rock. Remember, my poor little bit's screwed on the end of a sine wave. And if I don't have depth of cut, then it gets pushed around. It's inefficient. MSE goes up. The more weight I put, more indent, the quieter it gets. I'm pinning the bit to the bottom of the hole. Still have the sand leaf. Bit's not moving as much now. If I have a small change in rock strength, the bit will lose a tiny amount of depth of cut because the rock's harder. It's not actually the harder rock that's making me slow down though. I might lose 10% of my ROP due to 10% harder rock. It's this enormous increase in the bit's ability to shake laterally, whirl. So overall, I might lose 70% of my ROP in the next foot. Only 10% of that loss was due to rock hardness. The other 60% was due to whirl. So coming back to the question is that, for example, if you're in the Eagle Ford in South Texas and you get into more rock with more carbonate, it's actually harder. You'll see your MSE go up. It's very diagnostic. You're getting out of zone. And your bit is seeing it before your gamma ray is.
Yeah, because your gamma ray is going to be 60 feet back.
Way back, right. And so if I start steering, and I kind of know if I'm going up or down, if I start steering early enough, if I develop a technique and knowledge around this and understand physically that, yeah, that's whirl and that whirl's associated with carbonate, I can steer 60 feet earlier. And I can do milder steers. I don't need to be running a 183 motor, which has all kinds of bad effects. I only need a 115. I need a 0.78. I can do all kinds of things to take down my fundamental whirl, the things that are really wearing out motors. And these are long stories. This is the physics of stuff, right? But the ability to keep my steering mild, it's going to add footage to my 10K lateral, it's just all kinds of things. And that may come simply from figuring out how to see this more carbonate-rich rock. It's a good example of being physics-based.
So one thing you mentioned there I want to ask about real quick. Is there any benefit to having a higher bend angle motor when you could have a lower bend angle motor and it gives you the exact same motor yields?
Then not only is there not benefit, there's enormous problems with it. It is the root cause of so much of our drilling problem. You put that big bend in there and then you rotate that string and you're going to have very high lateral forces. You put a smaller bend and you have much smaller lateral forces. It's those lateral forces that are vibrating the bit and making it not drill well, slowing the ROP. Lower bends, drill faster. If you could keep everything else the same. But in addition to that, look at an actual bit that you pull. All the wear is on the outside cutters and all the other cutters are brand new, right? It's almost every bit you pull. That's whirl. That's that bend, partly, right? And you have whirl from other things. But you need to bring that bend down. The other thing that's really huge, bring the bend down, you'll drill faster and your bits will last longer. The huge thing, another huge thing is with lower whirl, I have better motor life. It's whirl that's wearing our motors. Your motors are pretty tough. They really are. Don't whirl it. Well, don't put as big a bend in it. Don't put a bigger bend than you need to steer. If you're drilling a 10 degree, you shouldn't have more than a 1.5 if you're building a 10 degree build rate.
So it sounds like there's a lot of positives on being able to just
lower bend,
reduce that bend angle.
The other thing, if you imagine that bend, when you slide, you put that same curvature in your hole. It matches the curvature in the motor. What happens when you go back to rotating? I've got a 1.8 degree motor, and to turn it 180 degrees, that first rotation, I have to not just flatten it, I have to flex it the opposite direction. Connections, bearings, the rubber, stator, what is that doing? For 3 feet, you'll see how torque. The reason is when you flex it over, you're putting tremendous force on the other side of the bit, and now you have depth of cut, indentation, and you start cutting that side of the hole. It takes about 3 feet to get your hole back to be over gauge enough that your bend can rotate without flattening the motor and putting force on the bit. As soon as it can rotate freely with no side force on the bit can't cut sideways anymore, and that's how big your hole is. That's how you go from small hole back to big hole when you rotate. And when you slide, you go back to gauge hole. When you rotate, you go back to a little bit bigger hole. The bigger the bend, the bigger that big hole is going to have to be before you achieve that. And the more stress and violence your motor is going to have trying to do the transition from your slide back to your rotate. This is what we mean by being physics-based. I just described something to you may not have thought about as soon as it wasn't complicated. I never did an integral or a differential, right?
No, sir.
But you
I got
a
the
different-
concept.
You got a different picture in your brain.
Well,
That's
you
physics
got,
based.
you got my brain thinking is like, how many times have you gone from sliding to rotating in that short little time period and had an MWD failure?
Right.
Like, if you could go back and look at all your MWD failures as a whole
There's some relationship possibly
and
there.
see if that is, you know, if
Well,
that's a point of contention there, like, is there a lot of stuff happening at
The
that
other
spot?
the other thing you want to pay attention to is your motor efficiency. It's going to take some downhole pressure tools and some things to study it, but watch what happens to the actual efficiency of the motor in your first 5, 6, 7 slides and rotates. Meaning how much fluid is it suddenly seem to be bypassing that's not creating RPM and ROP. A lot is going on when you do those slide to rotates.
Did you guys hear that?
And there's less of that going on if you use a lower bend motor.
If you guys didn't catch that, was to be able to start looking at downhole pressure, so sensors. So MWD, LWD guys that are watching right now, there's definitely an area to be able to study, to be able to look at overall performance gains via MWD. I have to be able to promote the MWD side as much as I can, since that's where I came from. All right, so we've got a couple more questions in here.
Oh, I didn't answer the other one.
Oh,
Smaller companies are easier than bigger companies. Okay.
I think there's a lot of truth in that. Just, I mean, probably in any and every industry is less bureaucracy, less people. It's easier to change the direction of a DD
Most
than
of
a
your
type-
bigger companies are
Titanic.
actually big international operators. They may have 10, 11 different drill teams. Each of those is like an individual smaller company. If you look at the dynamics of change and the training and the local content and local limiters and redesign, the whole process may be different from 11 different teams. So it's not that they're bad people. They're usually very bright. But their organization is more complicated. And the reason we did what we did at ExxonMobil, we were the only major that has a worldwide drilling organization, period. In other majors, you report to a local production manager or a regional manager. So there's a level of balkanization that doesn't exist at ExxonMobil. We had extremely good management, really good people. And we weren't fighting an organizational structure to start with. And most major companies are going to have to overcome an organizational structure more than you're running 7 rigs in the Delaware Basin, a small independent. You can do all 7 at the one time. They can all share, learn, talk, work together. You can have workflows that are consistent. Almost in 2 months, you can be up and running.
Wow. All right, so we got a couple other questions that have been texted into me. So let's see here. Parker LaVille, can you please give us an example of some training that yielded good results that you have conducted in the past? Wow, that is a that is a very big open question. You could probably talk for a couple hours on that one.
Parker I know Parker. He already knows the answers to all this.
So he's asking you a loaded question there.
He's setting me up here for to tell war stories. Give me an example where it hasn't yielded result. The training itself for the individual. The individual's a driller that comes to a class for 2 days, 16 hours of training maybe, goes back to the rig, they're immediately just aware of all kinds of things, like the bend in the motor being flexed. They change the way they work really quickly. The organization is harder to change. So, but the individual with more knowledge will simply agree, that makes sense, and they'll go do it. So I've had a hard time finding somebody or an example that didn't work for the individual. But I can tell you a story about a team that was off and running, but a manager didn't want to go to training, didn't choose to go to training, and they made one comment in a morning meeting that seemed kind of trivial. Team was already knocked 30% off, doing great. A manager that didn't understand what was going on made one comment, and it wasn't a big deal, but there was a senior manager, and everybody suddenly realized he didn't understand anything they were doing.
Oh, that's not good.
He saw everything as cowboy and risk-taking, and it's not what they were doing. So they went backwards, and it took them months to climb back out of that hole slowly. individuals who know things, how things work, are going to figure stuff out. But the organization is going to be more the challenge, usually.
So we got one here from Ryan Maynard. Are there any new big changes the industry is moving towards on the drilling side?
Automation. So the immediate, easy, low-hanging fruit is simply teach physics. That's the big change. That's the revolution we're in right now, is putting more and more knowledge into people. Not just drilling engineers, but especially people at the rig site. Going the opposite direction is automate the rig so I can have dumb people at the rig site. And that's been really the mantra for automation, is I don't have to train, I don't have to teach, I get performance, and I don't have to manage people coming and going and all this stuff. So, put knowledge at the rig site seems to be the opposite of automation. And I've been all about put knowledge at the rig site for 2 decades now. Well, I think what's turning out is we're going to automate slowly but surely more and more of the function of running the bit, choosing RPMs, choosing weights on bits, managing dysfunction, identifying limiters. We're going to automate more and more of that, but the team that has knowledge is going to always outperform the team that doesn't.
Yeah.
And there's a lot to that. I mean, we could talk a lot about automation. But, so for example, the automation we've talked about is really take the structure we've been teaching out of fast rail and this kind of decision tree structure for raising weight on bit and identifying dysfunction and all that. Take that and let the computer do it. And that became obvious as soon as we published MSE, mechanical specific energy, how to use it, how to make decisions and all that. And people started patenting and all sorts of stuff. But bit dysfunction is only one thing that can stop you from raising weight on bit. What if I can't clean the hull? What's the sensor? What's the metric? What's the early warning signal? What tells you to stop raising weight bit? What's the computer going to watch? Yeah. What about the auger? Well, I can put an amp meter on the auger and I can see when it's loading up. I'd probably, if I did, I'd learn a lot about the physics of augers. I could probably see early warning kind of signatures and all. I could do it, but it hadn't been done. I probably worked on over 40 different performance limiters in my career. If I miss any of those and the computer is raising weight on bit and I miss any of those, I have a train wreck. The computer's going in the ocean. Right?
Yeah.
So to fully automate we can automate a lot, but to fully automate is going to be a tremendous challenge, because it means letting the computer decide when to start raising weight on bit. And there's so many things that can make it not do that. So what's happening is that in the automation trials you see the computer, oh, we got a 30% gain. Well, they raised weight on bit 30%. And they got to 35,000 pounds, which is where the bit company said don't run more, and they had a set point and the computer quit. Well, what did we really automate? I could just run the weight on bit up to 30,000 pounds and got a 30% gain if I'd been willing to do that, right?
Yeah.
But when we automate, the bit company comes back and says, oh, maybe you can run 45. And now we run up to 45 and we claim another 25% gain. Well, but what did I really automate? So we need to be real careful with conclusions drawn from automation.
Yeah.
I think automation, data mining, all the things, all the tools that are developing are going to get better and better and better. And I don't have any doubt at all about that. But I still need that crew to sit there and understand, why did it stop? Because they will go further.
Yeah.
Secondly,
that becomes one of those things where it's not, you can't just say just work harder or just work smarter. You need to be able to do both of them, and
right.
So this is going to be one of those things. It's that there's machine, there's human, but if you can combine the two and give like the Centaur approach, and have those two, then you can definitely.
That human is always going to be sitting there punching set points. And as long as they keep capping performance, because they don't understand physically what to do about it, what they can see, do, and decide, they're going to be capping performance at much lower levels than what a trained, knowledge-based organization will go out and achieve. Second thing, the computer will never redesign a limiter. The computer, I put a set point.
Daddy, but for this row, there's one of those things that one of the blue names at me. But what is for one of the blue things
What do you
at
say?
me?
Are you tough?
Mhm.
Okay. Can you be tough for a minute?
Mimi need to come in there with you? Okay. You're on.
Okay.
All right.
So the computer won't redesign the auger.
All right, so I've got another question here, and I know this is from one of your students, Ricky-san, who's over at SM. Has Fred ever observed the industry move from slick to stabilized assemblies, especially in high-activity basins, Permian, to improve wellbore quality and drilling efficiency?
Okay.
I feel like that's a loaded question.
It almost feels like a battle line question, slick versus stabilized. What is happening that the industry doesn't understand is we're creating spiral patterns with bent motors. Bent motor points the bit at the side of the hole. You combine that with some other conditions, and you get a high side cutting capability at the bit, and the bit will create a spiral. In your hole, if you look down the middle of the hole, it's not as big as you think it is, right? Because it's actually spiraling. The middle of the hole can move off center every 4 feet by 2 inches. You advance 4 feet and the center's moved over 2 inches. You advance another 4 feet and the center's back over 2 more inches. These spirals are, any assembly can do them, but a bent motor wants to do them. And a bigger bent motor really wants to do them. So, minimize the motor bend, run a longer gauge bit because it limits how fast the trim cutters can cut sideways. There's a bunch of things you can do to reduce the amplitude of those spirals. But those spirals are the cause of all tight hole, not swelling shells, which is a total myth. Total myth. If a shell's enough to grab anything, it breaks and you get big hole, not small hole. That's a long story. It takes time to develop your belief in that, but I can do it.
I believe you could.
So the spiral is the reason you drill a stand down and you pick up and you see drag, or let's say a geometric feature that you cut into the hole. It's the ledge you create when you go from rotate to slides, or it's a spiral, or it's a micro dog leg due to a whirl off of a. Maybe there's only 2 or 3 things. It's probably a spiral. So what happens if I go stabilized? A lot of good things happen. I get a predictable build rate, more so than a slick that will. I'm moving my third compact point up and down by changing the curvature in it with weight on bit. I can't get to really high weight on bit because it gets even more predictable. Packed, I can go really high weight on bit. I can take the torquiness out with depth of cut control on the bit. I can get the high weight on bit. I get really predictable curvatures, much more so, as you know. And so there's all these advantages to pack, and I get lower levels of whirl in the BHA. So there's a lot of advantage.
Better energy back to the BHA.
The disadvantage is if you don't do something about those spirals and you go stabilized, they're all going to hang up on the spirals. And then you say, well, I can't transfer weight when I have stabilizers. It's not the stabilizers. They don't have any extra drag more than a long slick contact area would have that they're supporting when you're stabilized. That's not why you have drag. It's not the stabilizers. It's the spiral you're creating that the stabilizers are having to travel on. Don't create the spiral. Well, how do I do that? Longer gauge bits, high weight on bits so I don't have as much vibration. Don't turn your string at resonant speeds, and I teach how to find that and not do it. Manage whirl, and take the spiraling out of your hole, and now you have weight transfer, and now you can run stabilizers, and now you get all those advantages. If you run stabs and you don't understand how to manage that spiral and make it not happen, though, you're going to give up on them really quickly.
Yeah, there was one of the guys that I've spoken to in the industry, Alan Basicek, at Apache, and he's definitely told me that when they get into the lateral with their stabilized packed assemblies, longer gauge bits and stuff, that it gives them better predictability as far as how to be able to drill in the lateral to where they can slide less
Yeah.
and they can drill more with surface parameters versus having to
And they can use a low,
stop.
they can also
slide.
use a lower bend, like a 7.78 or a 115, something like that.
Yeah.
So what happens with your curvature as you drill is it is a product of the first 3 points of contact: your bit, your sleeve, and your top stave. Whatever curvature those decide is the curvature you get. If you're slick, you have, what happens is, as I apply weight on bit, I'm upside down here, as I apply weight on bit, that contact point is the collar. If I apply more weight, the contact point moves down. My curvature changes, so my build rate changes. So sometimes we like that because it gives us the flexibility to change build rate. But if I'm maximizing performance, I want to smash on it. I want 40,000 pounds on an 8 3/4 bit. I want tool face control, a depth of cut control or something like that. And I want only the bend that I need to build the rate I need. So that's why he's seeing that performance with
unpredictable build rates, because one stand you could get.
And if I have weight loss transfer and the thing unwinds, then I get a low build rate out of it. Yeah, it's unpredictable.
I've been a part of many of those conversations.
You should ask your friend how much pain and suffering there was, though, in getting the organization to move towards stabilizers. The things that we redesign, it's kind of up the hierarchy in things that are difficult to move toward, because you've got a directional driller who really does know how to get the job done right now. And they're not sure they can do that. And they're going to have a whole lot of new learnings if they haven't been a stabilized directional drilling person.
All right, guys, we're going back to the email, the Gmail account there that I believe is still up on the screen. You guys can continue to throw stuff in there. Are you good on time? Because
I'm good.
Okay.
Nowhere else to be.
I'm glad to be able to have you here. So we have a question. I have a question about bit RPM. Is there any limitation for bit RPM in a certain formation, such as lower weight on bit in Brushy Canyon? Should we always try to go with a higher speed motor to achieve better ROP? It's a lot of questions loaded into one.
There's not as much downside to higher speed as people think. So I've seen PDC, older people who grew up with PDCs in the 90s, or maybe 80s, had to worry about speed, overheating cutters, and especially in hard rock. Our cutters now are so different than that. We can turn PDCs 600 RPM and 40,000 PSI rock. I've seen that done. And not see really accelerated wear. So don't worry about speed. The Brushy Canyon is a conversation in itself. It's a hard laminated interfacial severity. And the bit gets loaded in odd ways on a bent motor. Remember, I'm drilling an oversized hole, bit's tilted at the side of the hole, so at any moment in time, you've got this side of the bit in contact and that side of the bit not, actually.
Yeah.
You're working one side of the bit. You go through these hard laminated transitions and think about, say, exiting one of those. Your nose gets in soft rock. They out-drill the shoulder, which is back in hard rock. The shoulder takes all the weight, all your 50,000 pounds. It's all on the shoulder, but that's only 3 blades. It's not just the shoulder of the bit. It's in this tilted kind of world. It's just a few cutters that have enormous axial load on them suddenly, and they overbite, and you over-torque and break the studs off. That's the Brushy, probably, one theory of probably what's going on in the Brushy Canyon. So what do? Well, you back off on the weight on bit so that when all this happens, you don't overbite as much, and you stay below what would break the studs off. That's why we're backing off on weight there. Speed, what I do with bit speed, if I can run a higher speed motor, is that I still have to back off on the weight, not to over torque, not to over indent, overbite, and over torque. But I get my ROP by just going fast, not by putting more weight. So we've gotten married to the idea of high torque motors. And what's happening in the unconventional industry right now is something different. The way you want to approach motor torque is you look at your differential pressure, take for that motor its torque factor, and calculate how many actual foot-pounds of bit torque that is, and start plotting that and start watching that all the time. That should be on your EDR screen, bit torque. It's being calculated from the differential, but instead of watching differentials, because that means one thing with one motor and a different thing with another, know your bit torque. Calculate that bit torque curve and watch it, and what you're going to learn is a lot about how you drill, what drills and what doesn't drill. What you're going to see is that maybe the bit torque associated with 50,000 pounds of weight on bit is 12,000 foot-pounds. Any motor that can deliver 12,000 foot-pounds is going to work for you. Go get the motor with the high speed that can still deliver 12,000 foot-pounds, and you will drill proportionately faster how much ever faster that motor turns. So we're out there with 0.17s, and almost nobody should be using a 0.17. When you play this torque game and all that in the Delaware or the Midland Basin, for example, we really should be looking at 0.29s. And because they now deliver the kind of torque that we're actually using at the weight on bit we're actually running. And they offer, well, 0.29 divided by 0.17. How much more speed is that? That's how much more ROP you're going to get. It's fairly linear with the increase in speed, motor speed. So going in, you can do the math. As long as you pick a motor that will deliver the torque that your bit is actually already needing, I mean, you got 0.17 motors that will give you 19,000 foot-pounds, and you're drilling with 8,000 foot-pounds, claiming that you're drilling fast because you have a higher torque motor. You're not using it. So go get a faster motor that'll give you your 8, and you will go faster. Torque comes from weight on bit. Once you hit your weight on bit limitation, whatever that is, whatever is limiting weight on bit, your next option is to either redesign that so you can put more weight, or go get more speed. To get more speed, go find the same bit torque, get that motor, and you'll get that speed. You'll get that increase.
Wow. Because I know that a lot of the companies that, you know, from my business, Gibbs Reports, obviously I'm working with a lot of the directional drilling companies, and you know, a lot of people are always talking about high torque motors, high torque motors. We've got to have these high torque motors. We need, you know,
Until as you raise weight on bit, you're going to need more torque. As you raise weight on bit, you're going to need more torque.
Yes.
But once your weight on bit becomes limited, say by the onset of stick slip, or
Could you go check on them, please?
Yes, I will.
I think they're about to kill that door in there.
Yeah. Okay.
Sorry.
yeah, once you max your weight out, then look at speed. It's not your first option, but it definitely, you're seeing higher speed motors. I've seen some even faster motors than that. Are they as reliable? Do they as durable? Do they last as long? It's your vendor. You have to have that new experience. If you're going to go for speed, you may have some learnings. It may work, may not work from a reliability standpoint. But if you see reliability problems, find a different vendor. Don't give up on speed too quickly.
Wow.
The bit has no problem at all with 400 or 500 RPM on the end of a 0.79 motor, rotary steerable motor. Yeah.
This is almost kind of like, from like a car perspective, you could think about, you know, if you've got this 7,000 horsepower motor, but then if you can't get that traction to the pavement, then it's all for nothing. So you got
I can't drive 55. I mean, 55 mile an hour zone with a. Anyway, you got the idea.
Yeah, you're almost overpowered in some instances, and so you need to be able to make some changes in the system to where you can apply what you've already got, or be able to optimize it. So that's, to me, that's one of those things I would not have expected, you know, just because you see so many people pushing high torque motors, high torque motors, high torque motors. So to hear that, that's pretty good.
Well, if you haven't maximized your weight on bit yet, they're right.
All right, so we've got a question from the guys over at Dynaqual. Eric Allen asked, what would you think about a downhole testing specification? We test a lot of individual test specification, but it's not like a uniform, or like aerospace or transportation industry using specifics. Do you think that there should be a downhole testing specification for vibration, shock, pressure, thermal levels?
Yeah, I think that's out of my wheelhouse a little bit. There are, as you know, there are many people looking at the issue of standardization of vibration measurement, and I don't know what they are suggesting we test. Downhole motor dyno? Is that what we're talking about? Or
I think, well, they do a lot of, I know the guys over there at Dynaquil, they do a lot of testing on NWD tools to be able to say, kind of shake them, rattle them and stuff, and then say,
So the idea would be to actually vibrate them downhole to see if they work, or?
Yeah, so they're doing it in a test function
Right.
to be able to say, okay, yeah, these electronics
I
achieved,
think I have no expertise in this, but my observation is that we need more data from downhole that tell us how things are working or how much dysfunction there is in it. What is the actual motor efficiency at any moment in time? That data will let us manage our business so that we don't have those problems to start with. And over time, we'll learn from that kind of data, and we may not have enough of that kind of information from downhole. So, we're running downhole sensors and all of that, but I'm not sure we're getting exactly all the data that we need. Oxy just wrote a great paper about wire drill pipe, their experiences, and it kind of opens windows if you start to thinking about what you can do with higher speed data. And most of what I think about that I want to know downhole, I need more data. I need a bigger bandwidth and all that. So automation, wire drill pipe, some things are coming together right now that may allow us to keep moving forward with more analytics downhole.
What about the recorded mode of the data? So this is something that, I used to previously represented a company to be able to go out and sell some of these things. And what the difficulty is that the scope of companies that we could really sell to was very, very small. And the fact that hey, we've got a whole bunch of data that we can help you with. And if they didn't really have a team or dedicated personnel to really be able to kind of bite into some of that data and be able to use it.
Yep.
It was pretty much just we just did this, but now nobody's going to use it. And then the problem with the smaller companies is they would look at it and go, okay, yeah, this could help us maybe on a couple of rigs or some of the smaller work that we're doing, but they definitely didn't have anybody in-house to be able to bite off on
Right.
it.
So we've had this conversation before, and feel free to answer your question. 'Cause you know more about this than I do. But that's a big challenge, right? We moving forward, you need fertile ground, and you don't have it. This is part where this conversation is chasing its tail now. You need fertile ground. You need the physics-based organization that understands stick-slip, whirl, torsional resonance. They don't need to do math. They need
I'll definitely say this. My sales calls definitely followed your path. So,
well, it's fertile ground, right? And we just have to continue to lean into the wind and create more and more fertile ground, or we're not going to use wired pipe effectively and get the value we can out of it, or data, downhole data and all that. I would also say that operators who are paying for this need to demand more from their vendors. I want more than vibration data. I don't want a package of PowerPoint that tells me what you saw. I want you to tell me why it's happening. And I think that's a challenge for the third-party industry, because you're learning from all your operators. I have to accept that you're learning from me, and that you will indirectly share that if you're in the business of also giving advice. There's that part of the business model, and I have to accept that. I don't care if someone else drills faster. I make money if I drill faster, right? And so there are all kinds of little pieces to the business model that need to be worked on like that.
yeah, it was definitely difficult for me because at the time, and still now, I don't have that. That's not my area of expertise, is being able to take all of that data and say, this is why this is happening, this is this, and this is this, and then go, here, I can tell you how to be able to fix those problems. I was the guy that says, I can get all of the data for you, but at that point in time, like for me personally, that's where my expertise stopped.
But that model would develop if the operator demanded it. Right now, the operators are paying for data and they're not doing anything with it because it's not coming with any knowledge, and they don't have the knowledge themselves for how to make change or what needs to be changed. So that's what I'm saying. The operators need to demand that people who do that service develop that expertise too. Now, or they partner with others who have it, or some kind of model. In my opinion, that would help both sides actually to grow, because this is really similar to a company's own internal data analytics group. They get data, they analyze it, and they're not making recommendations either. I'm a computer programmer, I'm a mathematician, I'm not a driller. I can tell you what the midpoint of the past has been through stochastic method, but I can't tell you how to redesign what's limiting you, or even what's limiting you, or why the data even says what it does, because I don't know how to do that. Even companies internally need to develop a different kind of organizational model that connects everything to the person that sits on the brake handle. I come back to where I was at the very beginning of this conversation. If you don't change, if whatever you're doing as an engineer, whatever you're studying as a data analytics group, or whatever data you're providing as a vendor, doesn't end up changing how somebody does their work, you didn't make me any money. I'm going to quit using you. I'm going to disband my data analytics group if they don't start providing value, and I'm going to quit running downhole vibration tools if I don't make any decisions from it. So what that means is that all these people out here have to take cradle to grave responsibility. If something's limiting, let's apply the limiter redesign idea, limiting you from changing how someone's really doing their work with the service you're providing, figure out what it is, understand the physics of it, and the physics we're talking about are organizational, politics, who has knowledge, who doesn't have knowledge, it's all kinds of things. And if you don't get that out of your way, then you're going to go out of business. Because in the end, if you don't provide value at the brake handle, you can look like you're doing a lot, and you might get funded and invested in, but it's not a sustainable business model.
I could not agree more. Okay, so we have, this one's labeled as an anonymous question for Fred, if something similar hasn't already been discussed. With the ever-growing push towards drilling automation, how can the industry make sure that technology is being developed and implemented deterministically?
So we've been talking around this already.
Yeah.
I'm not a fan of stochastic method that doesn't tell you why something's happening. And when they say what they're talking about is that how do we ensure we know why? And I just don't see an easy path there. The big question here is how do we get the industry trained more broadly and more deeply? I mean, all the way down to the brake handle, from management all the way down to the brake handle, to understand better how things work, how things really work. Operators have to invest money to do that. They have to lead, first of all. It has to be operators, probably. If they succeed, then I think other service industries can also develop something very similar. They can marry as they work together. As I said, I know one rig contractor's having a go at it. We'll see how that turns out. But operators, what they have to do is isolate some staff, sit down and build training material, go through their operations, their digital data, SPE papers, build their material around how things really work. Those things especially that limit them from raising weight on bed. Just simplify your question. Do step tests in your operations, your rigs, your area, identify what limits you, and go study those things and build practices that work. We already have them. You know, my class, you know, is one of the few things out there where they've really been consolidated in a really concentrated package, and all my students have all of that stuff out there, and all the companies I do. So there's material floating around. It's already consolidated and organized. But each operator really needs to build their own package for their area, their limiters, their operations, and more so their limiter redesign workflow that makes that plan, do, analyze, go round, round, and round. And then they need to work with all their vendors, do the training. So we did, in the first 4 years that we rolled out this kind of approach, which we call fast drill. It wasn't just MSC, it was this whole tamale. We spent $10 million training people that didn't even work for us. Of course, that's on a $5 to $6 billion a year drilling program. We spent $10 million, but we made $1 billion in reduced well cost, and we accelerated $2 billion in oil, into in-year oil. The rate of return on knowledge is just phenomenal. It's just phenomenal. But if I had sat down with management to begin with and said, well, I want to spend $10 million training people that don't work for us, I'm not sure how that conversation would have gone.
That would have been a hard sell. From my sales background, that's not how you make that sale.
Operators have to accept that they're going to have to become the center of training, knowledge. They're going to have rig crew change. Well, how are you going to deal with computer-based training? Someone comes on your location, they have no training, you sit them down, they go through a class on the computer. Do something, figure something out. Whatever your issues are, the operator really, I think, is a key thing. Industry organizations, I know the IADD is working on a training package right now we're trying to develop, which is kind of a self-paced video thing on vibrations. And it will introduce most of what I teach in my classes probably in the end. The professional societies can certainly do more to put more friendly, kind of training and better organized training out that is actually focused on performance and decisions, what can you see, do, decide, what can engineer, redesign kind of approach. We need more of that. In the service industry, right now, the service industry is where we expect most knowledge to be, really, in the service vendors. And so I think they have a tremendous responsibility to operationalize their knowledge, to ask themselves, okay, this is what I'm doing out here, but how do I change how what's between me and the person on the brake handle?
Yeah. And
take responsibility. Well, it's not my job. Okay, but you kind of need to make it your job, or work with an operator, figure out how you can affect the person on the brake handle and make that your ultimate metric for success, not ROP, not profit. Those are the thoughts that I grind on all the time. We have pieces out there of what we can do, but it's not what we normally do, and we need leadership to do it.
So let me ask you this, and we'll kind of wrap up here because we're going on quite a while, and I don't want to take up all of your time. And plus, I've probably got hungry kids in the other room that I've got to handle with here in a minute.
Yeah.
As far as what you offer to the operators out there, if somebody's watching this and they say, okay, that's it, we need to figure this out, how would they go about getting in touch with you or getting you to be able to come out and work or speak to their organization, whether it's operators and or even the service companies? Because I could see from myself right now, I think that some of the service companies not only being the ones to be able to get involved and get educated themselves because it's part of that hierarchy, but also being the ones to really push it, because if they perform better, right, and if they're on better performing rigs as a whole, right, then obviously they can tout that as part of their service. They can say, hey, we outperform a lot of the other rigs. Why? Well, it's because we have this approach. So how would somebody, or how would an organization go about getting in touch with you, and then what should they expect after that?
Okay, first of all, I don't text. I just want to make that clear. But you can Google me and my A&M, Fred Dupriest at tamu.edu. It's online. You can find me.
And Sam.
In the A&M, and Sam Neunert, actually, as well. Another professor at Texas A&M. But you can find us in the staff listing online at A&M PE department. The first thing I think that you would look to is who in your organization has been through this class of mine. And Sam's by the way, I'm not teaching that class. Sam Nornier is taking that class over, and he'll be teaching it in the spring, I think. But who do you have in your organization? And sit down with them and talk to them a little while about this. In the class, we actually do a case history where they have to design an organizational rollout for a typical West Texas small company. It's part of the class training. They're not just learning physics and practices. They actually, we just come back to the workflow over and over.
That is a very forward-thinking thing to do. It's not just teach them the textbook stuff, but teach them.
But see what I've done? I've sat out here and said, if I can't change this person, nothing I do at A&M matters.
That's true.
So if I don't teach students how to teach, number one, and secondly, how to look at organizational issues, then I'm wasting my time. So anyway, talk to the people in your organization with that background. Now, what happens is they've gone out and they found that as an individual, one-on-one is very difficult to move things sometimes.
And I've had those conversations with some of your previous students, and they're in that challenge.
Every one of these initiatives needs an actual person, a champion, and that's a really huge learning. Is that these are heroic events, efforts. They need a champion. They need a management champion backing them, both. And then other things tend to just kind of roll downhill and happen. But so look inside and see what you got. And I'm not the only one who knows a little physics. Look, vendors, put your own group together and try to pull knowledge together that's really related to your performance limiters. Read the limiter redesign papers that are out there. Again, the last Oxy paper is just another example where they're talking that process is what they're talking, which they've greatly enhanced, tailored to their own needs, which is what everybody needs to do. Yeah. When I get involved personally with a company, it's usually because they have a pretty good level of awareness already. They probably have one of my students who's already kind of shining and making a difference. Not because they're brilliant or different or whatever. They can simply explain a few things like, don't apply weight a bit slowly and why. And so then I work with them, on their data, try to help them define better what their opportunity is. And at some point management says, yeah, I'll really do this. But for me, I don't help unless I'm certain management really means it. And they really understand how much of an effort we will do some good immediately, and they love that. But if it's not going to lean into the wind for 3 or 4 years, it'll go away. They'll go back, it'll just become the new best practice, and they'll stop. They won't really achieve the change they could. And so if companies come to me and that's what they really want to do and they're really committed and they understand what they're getting into, then I put a lot of effort into that. I'm restricted, I'm kind of constrained by my time and how much of this I can do, and I'm also trying to be retired and continue my 45-year marriage so successfully. But they can just get in touch with me, and I'll tell them what's going on with me, and whether I become directly involved with them or not, I may be able to help them think through a few things they can do for themselves. So
big takeaway from that is, if you are one of Fred's students, remember in the negotiating room that you're worth a little bit more, and that's might be the reason why they're hiring you. So.
Or I set you up when you were a senior, and I just set you up again.
Excellent, excellent. So what I want to do here is that I know that I've gotten a lot of questions here that I have not been able to get to all of them. So I'd ask you this: what do you think about coming on and doing this again in the future?
If that turns out to be something people would like, I'd be happy to do that.
So no pressure on that one, just maybe throwing it out there. Guys, so what we'll do is we will gather up a lot of these questions that we've got here, maybe work with Fred, maybe even actually go do an episode at Texas A&M or at the somewhere,
like a
somewhere
good
in College
idea.
Station.
Yeah.
We can always come to you because this is all mobile and everything. And I want to thank you so much for coming in today and to be able to answer so many questions. I know I've still got way more just to be able to ask, but I know I've still got to take care of the little ones before they interrupt too much again.
No problem.
So, guys, if you have been putting out questions there, what we're going to do is I'll try to compile all the questions, especially any of the ones that we didn't get answered, kind of put those together, summarize them, and then maybe start working with Fred and see if we can do another show. And what we'll do is we'll just fire off a whole bunch of the follow-up questions. Hopefully everybody learned something here today. I know I did for sure. If you need anything else, or if you guys want to know any more about Fred, go ahead and check out the faculty website there at the Texas A&M University Petroleum Engineering Department. As always, guys, thank you so much for watching, and know your industry.